Jai Hind everyone, myself Puneet Saini, Assistant Professor, Department of Mechanical Engineering, Ajay Kumar Garg Engineering College. Today I will be discussing about a subject taught in BTech Mechanical Engineering 5th semester, Mechatronics. It's in departmental elective subjects and in external examination of AKTU. Total of 100 marks paper comes in the end semester examination. So we will start today by looking at the syllabus of our mechatronics subject. It consists of total of 5 units, and we'll discuss briefly about the syllabus of mechatronics. Then we will proceed with the unit 1, and essentially we will be studying the part 2 of unit 1. So before diving into that, let us first see the syllabus of mechatronics. So unit 1 is deals about the introduction of mechatronics, in which students will learn about how do we define mechatronics. Like it's an amalgam of 2 words, mecha plus electronics. Mecha means mechanics and tronics comes from electronics. It's an amalgam of 2 words, and generally in engineering we are integrating these 2 branches and we are getting the end product. So we will be discussing about that, and then we'll study about the evolution, its scope, how mechatronics evolved during the starting of the industrial revolution and now where it stands today. Then it deals with its scope, where it lies ahead in the future, and applications. That is the most important part of mechatronics, where its applications lie. Students will discuss about it and learn about it. Then we'll discuss about the basic elements and control of mechatronic system. What are the elements of mechatronics system? Like its electronic elements, its computer science related elements like chips and all, and mechanisms, if I talk about the mechanical equipments. So students learn about that. Then we discuss about the control of mechatronics. Control is essentially a very important part. Like if I want to control a mechanical system, or let us go with a very easy example, should I say, like a simple on and off button that we have in our home. Like we simply switch on the button and we get the lights, or we get the fans to help us in a specified way. So we control the working of a bulb or a fan by simply switching on and off a button. So that is how we control a system. So this is what control is about. I have just given you a very basic definition of control, but if I talk about complex engineering situations, their control is defined in a different way. But to just show you what a control means, I have given you a glimpse. So we'll be discussing about that just in a very short manner, in a crisp introduction way. Then we'll discuss about the advantages and disadvantages of mechatronics, and where it lies, how industries are getting benefited with the mechatronic system, what are the disadvantages of it, and its industrial applications like autotronics. Autotronics means we are integrating automobile technology, the way we manufacture an automobile, with electronics. As you can see, more and more of the cars which are coming today, they are coming with the connected tech. Like with the help of our smartphone, from here in my studio, I can switch on my car, I can roll down the windows, and I can start on the AC also if the temperature outside is quite high. So that is comes in the category of autotronics. Like with the help of Industrial 4.0 revolution, which deals with all the connected technology, with the help of a smartphone I could do that. So that is what deals with autotronics, meaning we are controlling an automobile with the help of electronics and IoT. So we'll discuss about that. Then we discuss about the bionics. It means bio, like our muscles, human body's muscles or an animal muscles, and how we can control it electronically. So that comes in the category of bionics. And last is avionics. So avionics means aeroplane, or we can say the objects which are flying, that comes in the category of avionics, and how the integration of avionics, or we can say an airplane with the help of electronics, it's helping us out in a quite significant way. So unit 1, part 1, which I am saying, like this is the part 1 of unit 1, it deals with the basic introduction of mechatronics, how it has evolved from various industrial revolution, beginning from early 18th century to the now, which is Industry Revolution 4.0. How mechatronics has evolved with the semiconductor revolution, from chips, robotics, IoT, and how mechatronics is being advantageous to us. So this is what it deals in the unit 1, and we will be studying it in a very short way. In part 2 comes the control system concepts. As I have discussed earlier, now we'll dive a little bit deep in the concept of control system, which is defined in a technical way as open loop control system and closed loop control system. We will be discussing that. In today's lecture only, I'll discuss about control system, and because it is a little bit a complex topic to understand this, so I thought it is better that in this lecture I'll be focusing on control system concept. So no need to worry about it right now. We'll just see how our syllabus looks like and what important topics are and where we need to focus in this. So unit 2 essentially consists of sensors and transducer. In any electronic system, there are always input devices, and that input devices senses some kind of signals and give it to our controller, or we can say our electronic chips, and that decides whether they have to conduct a specific output or outcome or not. So what sensors does is it senses the environment and gives some information to the controller, and then controller decides what they have to do. So sensors and transducers, they're nothing but the same term. They're a little bit different, and we'll discuss that in our next lecture. So they are essentially input devices. So in this unit, we will be defining the definition of sensors and classification. How do we classify it? Its performance terminology, like what is the range of sensor, span of sensor, hysteresis error, and non-linearity error. All of that we'll be studying in this. Then we'll be studying about the various displacement sensors. Also we'll be studying about classification, like there are linear displacement. So we'll be talking about the various types of sensors which are available in the market. Like if you want to measure any heat in the system, or you want to measure the fluid discharge, there are various types of sensors available in the market. So how to decide or how to choose them, we'll be discussing about that. And essentially we have been given in our syllabus, these are the types of sensor that we will be studying in depth. Like we will be studying the working and application of inductive proximity, capacitive proximity, photoelectric, ultrasonic, magnetic, Hall effect, tactile, load cells, LVDT, sensors and interfacing sensors in mechatronics system. So we will be studying about that with the help of a diagram and how it actually works, what are the basic principles behind it. So that part covers in the unit 2. So remember this, sensors and transducers are nothing but essential means to gather information from the surroundings, and that is fed to the controller. So next unit deals with the actuation system. So after getting information from the sensor, the controller decides whether it have to take the action or not. And if it want to take the action, then it is passed on to the output system. So output system is nothing but the actuators. It can be a DC motor, it can be a linear actuator or pneumatic actuators. So that we will be studying in this. So actuation is divided into, according to our syllabus, into two types: fluid based actuation and electrical based actuation. There is also mechanical based actuation, but you don't have to study right now in this subject. So in fluid based actuation, we will be studying about hydraulic and pneumatic based actuation. Pneumatic means with the air pressure we are doing something, and oil and air preparation unit, direction control valve, and we will be studying about direction and pressure control valves, actuated system, actuators and accumulators. All of these are driven by fluid based actuation. Next we'll be studying about electrical based actuation. Electrical based actuation, we'll be studying about the working of DC motors, electromechanical actuation, solenoids, how does a solenoid work, and principle of working of DC, 3-phase induction motor, stepper motor, servo motor, and their merits and demerits. So unit 3 deals with the output system. You gather information from the sensor, controller decides whether you have to do the task or not, and it gives a signal to the output system. Then they do the specific work, whether they want to do it or not. So that comes in our unit 3. Now unit 4 comes with the industrial controller. Now after studying the input and output devices and the control system, next come a unit for us, controller. What kind of controllers are there in the industry? Like PLCs, programmable logic controller. So to do the controlling in the industry, we use PLCs, and PLCs are driven by the ladder programming. So we will be studying about the concept of scan cycle. It's a term used in PLCs, and scan time, input output devices, how do we select them and their applications, and the programming techniques which I told earlier about the ladder programming. We'll be discussing briefly about that, not in detail. The next unit is unit 5, which is mechatronics application. So as this unit, as this subject mechatronics, it deals with the amalgamation of mechanical and electrical. So the main point that we have to study about it, its application. Where do we apply this mechatronic system? So unit 5 in detail deals with all the type of applications. It deals with the control of conveyor motor. How do you control it? Packaging unit, counter operations, domestic washing machine, and pneumatic pistons, automatic car parking system, engine management system, and other application manufacturing. So these are nothing but case studies, how mechatronic systems are useful in dealing with all of that. So this is the syllabus of mechatronics, and there are total of 5 units. First unit, let me again give a quick recap of it. Unit 1 deals with the introduction, evolution, and control system. Unit 2 deals with the sensors and transducer, which are nothing but input devices. Unit 3 deals with the actuation system, that are nothing but output devices. And then unit 4 we deal about the industrial controller like PLCs and how do we program it. We'll learn about the programming language. And unit 5 we deals about the mechatronics application with case studies, like how does an engine management system work, what are coins and counters, and how does an automatic car system work with the integration of mechatronic system. So we will be doing that. So let us now start with unit 1 part 2, which is control systems. So the contents of unit 2 are unit 1 part 2 are, we will be studying about the introduction to control system. What is a control system? What are the elements of it? And basics of open loop with example and basics of closed loop with example. So these are the 4 points that we will be covering in this mechatronics unit 1 part 2. Now let us start with what do we understand by control system. Before starting it, we will see what is an automatic control with the help of examples. So why automatic controls are required? Like control, as I have told earlier, we gather information from the surrounding with the help of electrical signals gathered from the sensors. Then the controller decides. Now you must be thinking about exactly what does the controller look like. So if you have heard about, like many of us use computer, right? So in computer there is an CPU, central processing unit, and it does all the hard work. In it there is a motherboard, there is Pentium chip, and there is i5, i6 processor. So that is essentially known as controller, because with the help of your mouse you send some signal to the CPU, then CPU do the work for you. The CPU decides whether that action has to be conducted or not, and your mouse is an input device which tells what to do to the CPU with the help of sending different kinds of command. So that is nothing but a controller. More example of controller we want to see is like Arduino board. It's a type of a controller. ESP, Arduino, Raspberry Pi, these are all our controller boards. All right. So something is known as which is automatic control, like to automatically control certain kinds of operation. And why it is necessary? For example, if I take example of autopilot in an aircraft. So when there is a really long flight, like nothing but 10 or 12 hours long, so it is very difficult for the pilot to constantly look on the controls, how the vitals of the aircraft are performing well or not. So there is a mechanism inbuilt in the computer in its aircraft which is known as autopilot. So the navigation or the path to the destination is already laid out, and the autopilot sees whether that path is being followed or not. So that is nothing but an example of automatic control, because it is checking whether the path it has taken, it is right or not. If it is deviated, then it makes sure that the aircraft follows the designated path. So that is nothing but control. So it plays a vital area of engineering in science, and it is more important in the category of space vehicle. And you will be mustering why it is important category of space vehicle. Like for example, we want to put a satellite in an orbit. So the axis or the rotation, at what angle we have to put the satellite, it has to be predetermined, right? So the exact coordinate is feed up into the system, and automatically as the spacecraft goes up, all the functions starts happening naturally, automatically, and it is put into the right orbit. So that is nothing but a good example of automatic control system. Another example could be numerical control of machine tools in the manufacturing industries, and design of autopilot, as I have just said now, in aerospace industry. Design of cars and trucks in the automobile industry. Governors. So governor is a type of device which is used to control the mean speed of the engine. So all of these examples are examples of automatic control. And let us also further study where it is necessary, like if I talk about the industry operations, so controlling pressure. Whenever there are boilers in an industry, if you want to control the pressure, so if the pressure is too high, we don't want that. So with the help of some kind of valve, we release the pressure. So that is controlled by the pressure sensor, temperature, humidity, viscosity, and flow in the process industries. So these are all nothing but example of automatic control. Now let us proceed further. So after studying why automatic control is important, now let us dive deep into the technical terms associated with it, starting with the system. So a system is a combination or an arrangement of different physical components which act together as an entire unit to achieve a certain objective. So if there are multiple systems, like you can take any example, like there are in an industry, there are various parts related. For example, there is assembly line related, there is a production line related, and if you are paying your attention on that, and they are integrated in such a way that one function of one is helping the function of other, then the whole is known as system, where different components act together as an entire unit to achieve certain objective. For the best example to study it in a layman language is a classroom. Like if I take an example of a classroom, apart from industry, it's a quite simple example. If I take example of a classroom, there is a professor who teaches to the class, and there are students, there are fans, and there are lights, there is a projector, and all of these things. So we can say all these are physical system, and all like professor and all the students, they are sitting, desk, benches, they are all are part of physical components which are interacting with each other, right? With each other. So a professor is delivering a lecture, and it becomes a control system. Like a professor becomes a control system. The professor controls how the class behave for the betterment of the result of the students. So he tries to regulate, direct, or command to students to achieve the objective, which is to input the knowledge to the students. So this is how a system is defined. Like a projector has the control of the class. So that professor has a control of the class. So that professor is known as the control who is controlling the class. All right. Now, basic definition. In next we study about plant. We have studied what is a system is. So the plant, a portion of a system which is to be controlled or regulated, is called the plant, right? It can be a piece of equipment, perhaps just a machine part. The purpose of a plant is to perform a particular operation, right? Example we can consider is a mechanical device, a heating furnace, a chemical reactor, or a spacecraft. So this is all constitute of a plant. Then, and what is a process? Any operation to be controlled is called a process. For example, you are melting a steel in a furnace, so that is a process, right? Example are chemical, economic, and biological processes. So here we are discussing about some basic definitions, and next basic definition is of a controller. So the element, how do we define a controller? The element of a system itself or external to the system which controls the plant or the process controller. The best example to study, as I have told, the controller is an on and off switch. Like with the help of switch on and switch off, what you can do is you can control whether you want to turn on the light or turn off the light for the control bulb. So that element of the system itself, it can be inside or it can be whole the system or external to the system, which control the plant or the process, is called a controller, right? And input devices, as I have told earlier about, it is an applied signal or excitation signal applied to the control system from an external energy source in order to produce specified output. So input can be, it can be any sensor. An output device, it can be an actuator. So what input does is, it is an applied signal or excitation signal. It senses the environment, whatever it needs to do, and it sends to the controller. Then what controller does, it does some kind of output. If it is a particular signal of interest or the actuated response, like if you want to switch on a motor, if you want to turn off a motor, it is an output device obtained from a control system when input is applied to it. Like this is an example flow chart, how it works. So there is a controller and it senses and command input. It can be from a sensor. Now then controller see if they want to manipulate that variable or not. Then it gives you the process. Like if they want to execute a process, then disturbance input is being fed and the output is taken to the whatever is the output. So this is how a process flow works. Next is the disturbances. Now disturbances are a signal which tends to adversely affect the value of the output of a system. We have to be very beware about the disturbances because they generally disturb our the entire ecosystem of the plant. So this disturbances has to be taken care of. It can be undesirable and unavoidable effects beyond our control. It is if such disturbance are generated within the system, it is called internal disturbance, and if they are generated outside the system, then it is called external disturbance. And the presence of disturbance is one of the main reasons of using the control, right? Now, after studying various terminologies of control system, we will now understand what is open loop and closed loop control system. To best study it, we have to take an example. Let us take an example of a traffic light. Now, in India, we see there are in metropolitan cities like Delhi, lot of traffic jam occur, right? So, on suppose let us consider a situation in which in a red light, one light is always green and other if it is a four-way, then one light is always green and other three are red, right? Now, if other three are red and let us imagine that the green light, there is no traffic in which green light is on, and because of the system which is integrated, let us suppose the green light stays green for like 30 seconds and there was no traffic in that 30 seconds, and on the other hand, where there are three red lights, on one of the red lights there was huge traffic coming from one way and other way is totally clear. So that 30 seconds on which the light was green and there was no traffic, it is no use for us, like it is a time waste and idle time. So the traffic system is not integrated in such a way that it can see if there is no traffic from other sides and there is a huge traffic from one side. So let us give that there is huge traffic from other side for green light of maybe for a minute or minute and a half. So that doesn't happen, right? If that would happen, then we can call it like there is some kind of feedback mechanism, like the traffic system itself is able to see whether the traffic is large or not, and it is correcting itself, and for that lane where the traffic is large, the green light is for quite long. But actually it doesn't happen. There is a fixed timeline for which green light will be there and the red light will be there. So if there is a fixed timeline and input and output are connected in such a way that there is no kind of feedback mechanism, then we call it an open loop control system. Any physical system which does not automatically correct for variation in its output is called an open loop control system. It is not correcting itself. Like I just give an example of a traffic signal light. If it would correct itself and make way for a green light for about minute and a half, then we can say that it is a there is a feedback mechanism. But in open loop closed system, there is no kind of feedback mechanism. Like there is a desired process response, for example, making a light green, and there is a controller. It decides color of light. Now there is a controller output process input. It is an output given by the controller and it will be the input for the process, whether to change the signal of the light or not. Then after the process is done, the output is given. So there is no kind of feedback mechanism, like output is not checked whether the correction of path is required or not. It is not checked, right? So that type of system is known as open loop control system. In this system, we can say that output is dependent on input, but controlling action or input is to be totally independent of the output or changes. So we can say that output remains constant for a constant input, like input is not changing. If I take example of the electric for the number of seconds which green light was on, it is not changing, provided the external condition remains unaltered. If external condition remain unaltered, the input condition doesn't change, right? Now, In any open loop control system, output is not compared with the reference input, as I have told earlier. And there is a presence of disturbance, and open loop control system will not perform the desired task. If there is a disturbance in that, the open loop control system will not perform the desired task, right? Such systems are not feedback control system. There is no kind of feedback, as I have talked earlier. And for instance, traffic controlled by the means of signal operator on the time basis is an example of open loop control system as given by me just now. Now let's see the advantages and disadvantages of open loop control system. These systems are very simple in constructions, right? You just have to construct constructing an open loop control system is quite simple because there is no feedback type of mechanism involved. Very much convenient when output is difficult to measure, like we don't know how to measure an output, and we want output to be vague because output is not much concern of ours. Then we use the open loop control system. Easy for maintenance, are not troubled with the problem of stability, and are simple to design and hence economical, right? Now considering the disadvantages of it, they are very inaccurate and unreliable. Because accuracy is not high, because you are not able to measure anything with the kind of feedback mechanism, so its accuracy is not high. These systems give inaccurate result if there is a variable in the external environment and sense internal disturbance in the system after the controller says. So these are some of the disadvantages of open loop control system. Now let us see some of the example of open loop control system. Number one is automatic toaster system. Many of us in our home has automatic toaster system. In that, what happens is you put on the bread, and for a specific period of time there is a red light and green light. The red light is on whenever you put on the toaster, and after the toaster is prepared, green light comes on, right? So what happens is there is a thermostat sensor, and as it senses the temperature of the system reaches a particular value, it make the cutoff, and it no longer heats. So what happens is it is working on some kind of heating mechanism. It is not able to check whether the bread which was put in the toaster is correctly baked or not. It is not able to measure it. So sometimes you see it is totally burned, and sometimes it is not properly cooked. So that is what the problem of an open loop control system is. The quality of toast depends upon the time for which the toast is heated. As I have just said now, depending on the time setting, bread is simply heated in this system. The toast quality is to be judged by the user has no effect on inputs. As I said, there is no effect on input. So this is a perfect example of automatic toaster system, open system. Now, next is traffic light controller. As I have described it earlier also, the traffic flow control system used on road is time dependent. Like there is a time box also there in the front, in top of the lights, red light, which gives us for how many seconds there is going to be red light, there is going to be green light, right? The traffic on the road becomes mobile and stationary depending upon the duration and sequence of the lamp glow. The sequence and duration are controlled by relays, which is fit in the relay is a type of a controller which is fit in the traffic signal and not dependent on the rush of the road. As I have discussed, it is not dependent on the rush of the road. So that is why there is no feedback. Remember this. There is no feedback in open loop. So that is why they are known as open loop control system. They are highly inaccurate, and the accuracy, if you want the good result, it depends on how good the system or the control system was calibrated for the results. Now coming to the closed loop control system. First type is open loop, second type is closed loop. As the word implies, I have discussed earlier, if there is a feedback mechanism involved, like whatever you are giving it as input and you are getting it as output, and output is checking whether the value which was fed to the controller, like this should be the output, it have reached there or not. If it is not reached there, it is taken as the error. And the system works in such a way that in a circular way that there is always a feedback mechanism, and it always tries to reach the predetermined fixed value. Error tries to minimize. So that is known as closed loop or feedback loop control system. These are nothing but same. A system which maintains a prescribed relationship between the output and the reference input. It always, as I said, it always tried to go for the fixed value which was given to it. Prescribed relationship between the same. The difference as a means of control is called a feedback control system. They are often, as I have said earlier, feedback or closed loop, they are one and the same thing. In practice, the term feedback and closed loop control are used interchangeably, right? As I've told about, there is always an error. In closed loop control system, an actual error signal, which is the difference between the input and the feedback signal. You give an input signal and you get a feedback signal, as I've said earlier. So the controller compare it. If there is an error, then it always try to minimize it, right? The term closed loop always implies the use of feedback control in order to reduce the system error. So this is what the working flow of closed loop system looks like. There is an input, there is a reference transducer, sensor, there is a reference input, like you want the prefix value, you can consider as a 15 for example. It goes to the controller, process to be controlled, a value comes out, suppose it comes out at 15.5. This value is again put feedback to the feedback path and it's check whether it is similar or not. Here we have feed as in 15 and it is coming out as 15.5. So there is an error of 0.5. So again, this signal is sent to this controller. Yes, there is a 0.5 error. You need to work in such a way that this error is reduced. So it will go on like this until this error is minimized to 0 or some value which you have put it. So RT is the reference input here. ET is the error signal here, like this 0.5. CT is the control output. Here is the CT and here is MT, manipulated signal, and BT is the feedback signal which is sent here. So this is the flow chart of closed loop control system. Advantages: accuracy is always high. Number one, it senses environmental changes and it go well with the disturbances. Go well with the disturbances. There is reduced effect of non-linearity and error. And disadvantages are they are very complicated and time consuming. To develop a closed loop system is very difficult and challenging. The system tries to correct the error from time to time. Like I said, the tendency to overcorrect the error. Like if there is an error of minute, like point in terms of 0.001, if you have not feed the codes correctly, then it will go on bouncing and bouncing and bouncing, and it will take quite a huge lot of time to give the correct amount of output. If the stability problem is severe and must be taken care of while designing the system, right? So the best example of closed loop system is a human being. Like our eyes see something, if there is something, put it on the table. Our eyes sends a signal to our mind, which is nothing but a controller, that you need to take your hand to that place, and that you have to travel that much amount of distance. If that is very far, then we have to move forward or backward depending on the object. And then we use the signals to grab it with the help of our hands. So this is the best example of human being. Like we always correct it. If it is far away from us, we try to reach it by moving to some distance. So the best example of human being, if a person wants to reach a book, on the table, position of the book is given as the reference, right? Feedback signal from eyes. Compare the position with the hands, how far is it from us, and the brain manipulates this error and gives signal to the hands. So this is what a closed loop system looks like, right? Now another one is home heating system, in which there is a thermostat, a sensor, like a heater. In winters we keep it at home, it sends the temperature. If the temperature is getting the adequate and it is the prefixed amount which is given to the heater, then it automatically goes off. Those there is a sensor, that is thermostat. It compares the temperature of the surrounding with which is the value which is fed. So this is a very good example of control system. So if I compare open loop and closed loop, we can say that any change in output has no effect on the input. That is feedback does not exist. In with this, feedback exists. Number one difference between this. Output measurement is not required for operation of system because there is no feedback, so no output measurement is required. And here output measurement is necessary. Feedback is absent, feedback is present. Error detector is absent, error detection is present. It is inaccurate and unreliable. As we know, open loop system tends to be inaccurate, and it is highly accurate and reliable. Highly sensitive to disturbances, less sensitive. So these are nothing but all of the comparison between open loop and closed loop. It's very easy to understand, and I will proceed it further. So that will be all. Today we have discussed, just to conclude, we discussed about the closed loop and open loop systems, how do they operate, and with some examples of it, what is an what is an automatic control, and we also discuss about the syllabus of mechatronic system, what are the complex part and how we are going to proceed with it. So that will be all. Thank you.